All right, here's the next section for your geometry. This is chapter 5, section 4, 5-4, inequalities in one triangle. Okay, this is a very, very simple concept. For this particular one, it says in a triangle, okay, at the very top of your note packet, please go to your note packet and go to section 5-4, but it says in a triangle right here, no, the longer sides of the triangle are across from the larger angles, and vice versa. So what we mean by that is here we have a theorem that says if two sides of a triangle are not congruent. In other words, we know that side B here, side B on this triangle is greater than side A. Okay, so side B is longer than side A, then the larger angle lies opposite of the longer side. So the larger angle would be angle B right here that's opposite of the side. So they say the measure of angle B has to be greater than the measure of angle A. Okay, that's fairly self-explanatory. If it's a longer side, then the angle across from it is a bigger angle. And it says vice versa, the converse of that theorem. If two angles of a triangle are not congruent, that means they're not equal, then the longer side lies opposite the larger angle. So if I know that the measure of angle B is greater than the measure of angle A, then I know that the side opposite, in this case side B, has to be longer than side A. Okay, so what does this mean as far as your worksheets go? Okay, it says which angle of this garden bed has the greatest measure. Okay, we're not going to be able to tell what the angle measure is, but we're going to be able to tell which one's bigger. Okay, so which is the greatest angle? I look at the side lengths. You got 14 inches here from D to F, you got 8 inches from F to E, and you get 10 inches from D to E. So which angle, D, E, or F, is the bigger angle? Well, you locate the biggest side. 14 is obviously the longest side, so the angle that's across from it, angle E, has to have the greatest measure because it's across from the longest side. Which angle would be the smallest angle? Well, find the smallest side. Okay, here's 8 inches, obviously between those three sides, 8 inches is the smallest. So if I go across from the smallest, I would say angle D is the smallest angle measure. I don't know exactly what the angle measure is, but I know it's the smallest. Okay, we can also do this with sides. It says which side of the triangle is the longest. Well, if I look at the angle measures here, and I'm missing an angle measure right there, but can we determine what that angle measure is? Sure we can. We know two angles of a triangle, so we add those up, and we subtract from 180. I take 180 and I subtract 98. Okay, I'm going to get 82. This is an 82-degree angle down there. Okay, so yes, we have to find that. Okay, now, which is the longest side? We'll find the biggest angle. 82 is the biggest angle. So if I look opposite of that angle, I see side A. Side A has to be the longest side. Which side is shortest? Well, which angle is the smallest? Okay, 27 is the smallest angle in that measure. So if I look across from that, I know that side B is going to be the shortest side. So imagine trying to build a triangle out of 3 segments whose lengths are 14, 6, and 5. Could you do it? Okay, here are my 3 sides. Is there any way I could make that connection there? Okay, and no, you wouldn't be able to. These sides aren't going to reach each other, so we cannot construct a triangle using those 3 lengths. It says if those 2 shorter sides don't add up to more than 14, then they're not going to reach each other at the top. So you've got to take the 2 shorter sides of the triangle and you've got to add them together, and that total has to be greater than the 3rd side. Okay, it's called the triangle inequality theorem. The sum of the 2 lengths of any 2 sides of a triangle is greater than the length of the 3rd side. So if you have segments with lengths 46, 52, and 71, can you make a triangle? It says, do you have to check all three combinations listed, or can you just check one? You can just check one. You want to pick out the two shortest sides, so 46 plus 52. That sum has to be greater than 71 in order for us to be able to create a triangle. So if I add those together, 6, that would be 8. That would be a total of 98. 98 is greater than 71, so yes, I can create a triangle out of those three links. Okay, and then it says, suppose two sides of a triangular frame measure 15 and 19 inches. What is the range of possible lengths for the third side? Well, we have to consider two possibilities. What if the missing side is the longest? So let's say I've got the sides that are 15, 19, and here's the unknown side. Let's call it x. Well, if these two sides, if the one that's missing is longest, these are the shortest sides. So 15 plus 19 equals, let's see, that's 14, that's 34 altogether. We said this sum has to be greater than the third side. So that third side cannot be longer than 33. Okay, it can't be longer than 33, otherwise these two short sides wouldn't be greater than it. We wouldn't be able to make a triangle. Okay, so 33 on that one, if it were the longest side. And what if 19 is the longest side? So let's set this up differently. Okay, let's say that the 19, that's given. So I have the third side, I have the 15, and I have the 19, where these two are the shorter two sides. Okay, well in that case, the 15 plus the x, those two shorter sides, has to be greater than 19. If I subtract 15 from both sides, I get x is greater than 4. So x has to be greater than 4, put 4 here. Okay, so I'm going to say 4 is less than x is less than 33. Okay, now it can't equal the third side, it has to be greater than the third side. So x, here's my range of values, it's going to fall between 4 and 13. Okay, you have a worksheet that you can start working on.